Okay, we're looking at example 3 on section 3.4. This one is just a graph that we're going to look at here, and I've attempted to replicate the graph that you see on the worksheet. I hope it's pretty close to what it looks like on the worksheet. So what we're trying to find is the x values where the function does not have a derivative. So right above that, we want to take a look and see when does a function fail to have a derivative at a particular x value. So you can read about where the derivative does exist. All three of those things have to happen. The function has to be continuous, has to be smooth, and it can't have a vertical tangent line. So really what we're interested in is below that. The derivative does not exist when any of the following conditions are true for a function at a point. All right, so condition 1, f is discontinuous. So we've talked a little bit about continuity already. A function is discontinuous if, when you're graphing it, remember that if you have to pick up your pencil to graph it, then you have a discontinuity. So it seems that right here, this is what, 1, 2, 3, 4, 5, at x equals -5, we've got this vertical asymptote. That's a discontinuity. So that's a place where the function is not going to be differentiable. So not differentiable, or the derivative doesn't exist, at which x values? So the first one we found was x equals -5. And the reason is because if you check, f is discontinuous. So it's discontinuous there. Okay, and being not continuous means also being not differentiable. Sharp corner. Okay, so that means if you see like a peak or any sort of sharp corner on the graph, then it would not be differentiable at that place as well. So if you notice right there, that is actually a sharp corner on the graph, and that occurs at -3. So at x equals -3. And again, the reason for that, sharp corner. And really, the reason for the sharp corner, for the derivative not existing there, remember that the derivative represents the slope of the tangent line. So the question really becomes, well, how can I draw a tangent line at a sharp corner? I mean, is it the tangent line going in that direction or the tangent line going in that direction? You can't tell, so that's why we just say the derivative doesn't exist there. Right there, we've got a hole in the graph, so that's another discontinuity. So at x equals 0. And when we talk about a function not being differentiable at a particular x value, it's the x value where we're interested in, not the y value. So at x equals 0, and again, the reason for that is there's a discontinuity there. Discontinuous. Remember, a hole in the graph means discontinuity. X equals 2. We've got another one of those sharp corners. So that's the reason there, sharp corner. And then finally, the last one, the vertical tangent line, that's actually happening right here at x equals 4. You've got a vertical tangent line. And what does that mean? That means if I attempt to draw a tangent line right there, the tangent line itself would be a vertical line. And so why is that a problem? Well, remember that the derivative is the slope of the tangent line. But what's the slope of a vertical line? The slope of a vertical line is undefined. It's infinite, basically. So that's the reason. If the slope of the line is undefined, then the derivative is undefined. So at x equals, what did we say, 4. At x equals 4, we have another place where the function is not differentiable, and that is a vertical tangent line. Okay, so that's all of them. That's all the discontinuities on this particular graph.